Okay, so I've successfully calculated the test statistic, and assuming I haven't done anything incorrect, it appears that our test statistic is 514.92, which is pretty large. So this is looking like a pretty good reject H naught, but we still need to find where our alpha chi-squared value is, which we could have done first. So if we remember, our alpha that we're looking at is 0.05. So let's write our alpha here. And remember, our degrees of freedom are the rows minus 1, which in this case was 2, times the columns minus 1, which is 4 minus 1. So in this case, we get a degrees of freedom of 3. So let's go back to our table so we can figure out what our chi-squared value is for this alpha level. So in this case, we had degrees of freedom 3, an alpha level. So 7.815 is going to be our chi-squared value that we're looking for. So if we go, oops, wrong thing. So if we go back to our chart here. So basically this is our alpha here. And so what was it, 7.85 or something? 7.815. And so our chi-squared value we found is would actually be like way over here somewhere, 514, like if this graph kept going and going and going. So it's going to be way over here, 514.92. So it seems pretty clear that this is going to be a reject H naught, considering it's totally off the graph altogether. But let's check the p-value just to verify. So in this case, we're going to do the chi-squared CDF. Our 514.92, comma 100,000, comma our degrees of freedom, which is 3, oops, so second vars, so 514 point, make sure I get it right here, 92, comma 100,000, comma 3, and yeah, so in this case we get it like not even an exponent scientific notation, it's just straight 0 in this case. So our probability is exactly 0. So our p-value is 0, so which is clearly less than alpha. So in this case, since p is super less than alpha, we reject H naught. So we can see there's sufficient evidence to prove that your demographic whether you survived or not. And one of the things that's kind of nice about doing it this way, even though it takes a long time, is it kind of shows where the discrepancy actually lives, like in your O minus E matrix. So notice in our O minus E matrix, the women, the boys and the girls, were all pretty much exactly the same when you looked at their minus, but you can see in the men's column that that's where the big difference is, because in reality, if there wouldn't have been any difference, like these O minus E's would have been pretty close to the same number. But in this case, you can see that the men is significantly higher survival rate than the death rate for the men. So it seems like, so it not only is that you can figure out that it was different, but it looks like the men survived at a higher rate than they should have compared to how everybody actually died on this Titanic. So it's a lot of work, so trust me, I know there's a bunch of examples for you guys to try here and stuff like that. So let me know if you get stuck, have any questions, anything like that. But it's kind of cool because if you were to try to do this, with this much data, like what you'd end up having to do is a individual hypothesis test for each individual one. So like I'd have to test men, then I'd have to do a hypothesis test for women, then I'd have to do one for boys, then I'd have to do one for girls, and kind of test each one of them. So that's what's kind of cool about this chi-squared is it allows you to do multiple hypothesis tests all at the same time and stuff like that. So it is a lot more work, but again, it's probably less work than having to do 4 individual hypothesis tests for each one of these guys. So, well, good luck with it. Let me know if you have any questions or anything, and I'll be around the computer all day if you get stuck.